Okay, so in this video I'm just going to show you how to set up ODS Studio on a Windows machine just from scratch, from a plain install. Now, first thing to do is to go to the ODS Engineering website and go to the download section here and download this first one here, the ODS Studio Windows binaries. So add that to your cart. There you are. And now go to your shopping cart and you want to check out, right? Now if you don't have an account created by this stage, you want to set one up, but I've actually got one here so I can actually log in, and I'll just log in with this account. And you'll see I've already set up billing addresses and all that sort of stuff. Now the key thing is we don't have to pay for it because it's all free here, so just go to free order. It just helps us to keep track of how many downloads we've had and who's using what. So go to review order. It won't take you through the pay gate or anything. You'll bypass all that, and then you submit the order. What that then does is if you go to your account, you've now got in your files there, you've got the download available. And what's really good about that is you can in the future just keep coming back to here to download new updates and so on and so on. When we update to new versions, it'll pop up here in your downloads. Alright, so you could click on that and start downloading, but I've already done that, so that's created this setup script here. So you download that and just double click it, and up pops your dialog box here. So what you need to have is Blender installed, as you can probably see. So we got to maybe install that Blender. Now just before we do that, what I'll just do is show you where we got that from. You have to download Blender 2.63, so go to blender.org, download Blender, older versions, go to your releases here, go down to 2.63 and 2.63A, and you can right click and save that, right? That's for 64-bit, this is for your 32-bit here. So in any case, I've already downloaded that and it's here. So I could just go yes, install that, yes, agree, install, and away it goes. So just let that do its thing there. Alright, finish that. And what that should have done is install to your C drive, program files, Blender Foundation Blender, and there it is. So now we can go back to our setup script and go next, and it's found Blender this time, accept the agreement, go on. So here it says ensure that you've got Blender 2.63 installed, so you wouldn't have been able to get to this stage if you haven't got Blender installed, but you got to make sure it's 2.63A, right? You can also, the OpenFOAM binaries will only be installed if you're on a 64-bit machine, so that's if you're on a 32-bit machine, it just won't install OpenFOAM. You'll still have the CFD add-on, but it just won't be able to run the actual CFD calculation. So then you go, where do you want to install it? So you could leave it as a default directory there, that's fine, ODS Studio. Give it the directory where your Blender install was just done to, and that was there in C drive, program files, Blender Foundation Blender. Start menu, install all that. So what this is doing is installing all of the Radiance files. It also installs all of the OpenFOAM binaries now, and it creates all of the environment variable and links to your path and all of the bat files that you need to launch OpenFOAM. And it also should create a nice little desktop icon to launch ODS, because when you launch ODS you need to actually start OpenFOAM before you start your instance. It also installs the Microsoft HPC pack. Now at the end here you can see it's created that ODS Studio link to your desktop, so it is actually all ready to go and you could actually run it at this point. But if you want to do EnergyPlus, which does your energy modeling, you need to actually download these third-party programs. We couldn't package EnergyPlus in the actual download script because of licensing restrictions. So what you do is go to your EnergyPlus website and download EnergyPlus. So the way to do that is to actually just click on that link, go to EnergyPlus, go to download EnergyPlus, create an account. I've actually already set one up here. So you should just be able to log in and download your relevant version here. So I've done that already. So if I go back to the desktop, you'll see here, and here I've got my actual key that I need to install. So I'll just install that. That's the key that I need. So I'll even install that view factor calculation. And now it wants that password, so I just copy that password there, which is given to you when you download EnergyPlus. Install that. And just wait for it to get done. Now the one thing you need to do in order to be able to run EnergyPlus from within Blender is you need to be able to make sure that your EnergyPlus directory is on the path. Okay, so what this is doing is this is installing to C drive EnergyPlus version 7, right? And Blender, when it runs, it needs to be able to find this runeplus.bat. Okay, it needs to be able to find that. So this needs to be on your path. I'll tell it to associate files and finish. And the way that you set it on your path is that you have to go to Control Panel, System, Advanced System Settings, Environment Variables, and just scroll down to your path here. Edit that, and at the end just put a semicolon and then paste the path that you just installed that to. There you go. So close all that down. So that's EnergyPlus is now installed, and what you should be able to do is open up a command prompt just to test it. And if you type in run eplus, you can see it has actually found that command and it's trying to run it, but it tells you it needs an input file name and a weather file name. So that's that done. The other thing that you need just to finish up the setup is you might want to install, you've got to set up your environment variables. You also, to be able to look at the CFD results that you get, remember this is all optional stuff, but it's highly recommended to be able to look at the CFD results. You need to install ParaView, and just to show you where that comes from, you can click on the link and that should bring you here, and this is the ParaView, so just go download the latest version of ParaView. Okay, ParaView is a CFD post-processor, so you run that. Yep, I agree, install all that stuff. So ParaView is a very powerful CFD post-processor. Obviously you can't post-process all the CFD results inside of Blender because it's just far too much data. You need a particular program to handle the gigabytes and gigabytes of data that comes out of a typical CFD run. And ParaView is perfect for that type of analysis. And we'll put more tutorials up on the ODS website showing how to use that piece of software, but there's a lot of tutorials online already, and if you need help, you can just Google search ParaView OpenFOAM, and that's all that done. And then the last one, which is highly optional, you really don't need it, but it's sometimes good to run, is OpenStudio, which you can get from here. If you just double click the link, you see what is it, and what it is basically it's what ParaView does, but it's for EnergyPlus. So it's a post-processor for EnergyPlus. It also has SketchUp plugins, so you can do a little bit like what ODS Studio does inside of SketchUp. But these two approaches sort of complement one another. ODS Studio does stuff that OpenStudio doesn't, like CFD and being able to map pressure coefficients from the outside of a building on to do detailed airflow networks and all of that sort of stuff. So you can just go to the downloads here. Again, go to the Windows download, type in the login again, get that download, and you'll get this file here. So you just install that one. And you agree to all that, install that. And once that's all done, then you're pretty much done. So I'll just wait for that to finally finish. Close this down. And that's everything that you need to have an up and running, fully functional ODS install. It's got OpenFOAM, it's got Radiance, it's got Open Studio for post-processing EnergyPlus, it's got EnergyPlus. Finish up there, and away you go. Now, they're all the downloads that we use, so I'll just move them over there. This is here to start ODS Studio. You could click on Blender and start it running, but what's the problem with that is, and you can still start up all the add-ons, they're all still there. The problem is though, when you go to actually run a CFD result, it won't be able to find OpenFOAM, so you'll have this problem, and it'll give you all sorts of errors, right? What you need to do is actually use the actual link here, because what that does is it sets all the environment variables and ensures that all of the OpenFOAM programs are in the right, able to be found and on the right path. So you can see that when you're running ODS Studio, you also have this window here, right? So this is your terminal window, which you'll want to look at pretty often, just to see what's going on. So all of the output from CFD and OpenFOAM and Radiance and everything gets reported into that window there. So you can really test a case really quickly. If I scale this up, I'll just get rid of that light there. And if I just do one of these really quick models here, and I'll grab that way, and I'll extrude this in the Y. There we are. And if I now go around, in the new version of ODS here, they've got really cool features to quickly make models up. So make sure we've got something started up, say like Radiance, and it'll automatically start all the dependent modules. And if you now go inset faces individually, it'll create all of the windows. You might want to inset it 20 centimeters or 50 centimeters, do it 20, and then I'll scale it in the Z direction like that. And then what you might want to do is just add some windows, and I'll grab that negative, might turn them down. You might want to grab this side as well. Whoops. There we are. Grab X that way, and I might want to extrude Y 0.5, make these little shading. I'll leave the southern side there unshaded. Then we'll just want to pull out these windows that we did before. There we go, parent them out. Doing this very quickly, you want to set this as a window type material, set it some transparency. In here you might want to display them as transparent so that they're clear. You want to maybe skin the interface there. You want to set the radiance property type, so you want to set that to a glass because it's a window, and the rest will be an opaque plastic type material. And you want to view the camera, go into here, maybe set that camera, if I unskin the interface, you can set it to degrees, maybe 100 degrees. There we are. Just fly around a bit more. That gives us a nice wide angle view of the room, like that. You then want to actually just make sure that you have your sun path turned on, because you can see the time down here in the bottom right, and I'm just using the right arrow key just to move through to like a reasonable time. So let's say 11 o'clock. Got everything selected. Save this to your desktop, say. I'll create a new directory called test. So there we are, test there. And we go back to we'll skin the interface one more time just to take it back. Here's our Radiance menu. We'll set it as an intermediate sky with sun. Across 4 CPUs, 3 bouncers. Never mind, we'll leave all the rest as default. Save that, we write the case files, and then we can render the frame. And what you can see here in the terminal window, you can see the system calls that's going out to Radiance. So it's found all the ground ambient level and it's calculating the daylight factors and so on and so on. Just so you can see what's happening there, I'll open up the image. It's taking a while to calculate. Alright, this takes a little bit of time. And the Windows machines, the only problem with them is that on Windows you don't have really nice multi-processing capabilities with Radiance and the likes. That's why it's a little bit slower than a Linux machine. On a Linux and Mac, Radiance will run across as many cores as you have. So if you're running a 12-core Mac Pro, this will go 12 times faster, obviously. And if you're running an even bigger server, you know, you just get that scalability is really nice. So Windows, you know, is always going to be a little bit handicapped in that regard. So I can open up the images here. There's my rendered Radiance image of the above scene. I can open up the actual irradiance map, and there's that. I can actually go down here and go to the false color menu, get the daylight factor, and turn this into a false color image. There we are. You could also open up that image again and actually threshold it, so I could get the threshold wherever it's above, say, 6% daylight factor. And you can just see these little corners here. So, alright, so that's Radiance. What I can also do is collapse all that away, maybe get rid of that camera. I might move it to another layer or something. And going back to this, I could grab it in the X-4. There we go, to center that whole model a little bit better. I could again start up the CFD module now and go add mesh CFD domain, and that will put a box around the domain. On the max Y here, I could actually just put CFD, if I go to the object CFD menu, put a fixed velocity boundary condition of -5 or -3, let's say. And on the min Y, you want to put a fixed pressure out only. You'll also probably want to select your objects there and set their mesh level to about 3 and copy it to selected, so that'll set your mesh levels. You can then go back here, turn on multi-processing, set 2 processes in the X and Y. That'll divide this box into 4 boxes overall. Leave the solver as default. Probably want to just leave everything here as default as well, a 1 meter base resolution. Then you can select everything, make sure that everything's yellow, and then you write the case files, and again you can see here what it's doing, and you can mesh that case. And here you can see it's actually going through Snappy Hex Mesh, creating the CFD mesh. Alright. So that's it, nearly done. And it's doing it across all 4 CPUs as well, so I'll show you that in the next step. Then that's created the actual mesh now, and you could, if you wanted to, open that up in ParaView and have a look at it. So where's ParaView? ParaView, there we are. And you just want to go to wherever you've made your case. And test foam, OpenFOAM, case.foam, and open that one up, and you probably just want to apply that, and you can actually see the result there. And if you go to wireframe view, you could actually see our CFD mesh is there, so it's all nicely done. A bit of weird stuff happening there with this version of ParaFoam. I might go back to an earlier version of ParaView, because this is a release candidate. So, any case, it looks like it's kind of working. And then you go here. So we've actually done the full mesh. The mesh exists. and here to set the actual number of iterations you want to do, the write precision, so on, so on. Leave it all as default and just press the run case directory button. And what that does is you'll see it's actually decomposing the case down out to your 4 processes again. Allow that. That's just allowing your firewall to actually use OpenFOAM to get through the firewall. If you look at your task manager here, you'll see that I'm actually using 100% of the CPU. So it's properly multi-processing, and it's just going to cruise through and do all 500 iterations. So when that's done, what you can do is, if you want to actually stop it a bit early, you can actually change this to next write and write the control dict. Okay, what that will do is it'll OpenFOAM reads the control dictionary at runtime, and it'll actually read that you want to stop it at the next write, and then it's actually going to stop. And when it finishes, it'll reconstruct the case again, and here it is putting it all back together again. Alright, so I think that's done. And we should now be able to actually open up ParaView, but I'll use the old version of ParaView, ParaView 3.14. And we can go back again to the desktop and open up our foam directory. And this time, remember though, to go to the last time up here. It's very important to go to the last one, otherwise you'll just see a whole bunch of zeros and you'll wonder why you can't see anything. Again, we've got the same mesh, nothing's really changed there, but if I take it back to outline view, I should be able to put a slice through this one, Z normal at 1.5, and there you go. You can visualize that as the U velocity, and that's your result there, CFD result. You can add a color legend to it. You can also, if you wanted to, turn off that, I could add some streamlines. So I could put that just upstream there, around there, and apply that. Now, if that happens in Windows, see how you've got this with your streamlines? If this happens at all, the way to fix that is to go back to here, and at the very bottom of your properties, so on your base case properties, and at the very bottom, after you've done all this stuff, turn off this decompose polyhedra, okay? And that will just take a while to read that in, and there you go. Now you've got nice smooth streamlines, which you can actually go back and color them by the U velocity. You can add filters on them to make them more like a tube, which is really nice. So you can make that 0.05, let's say, and there you go. You've got actually thick tubes now. There you go. You can also bring in from the constant tri-surface CFD geom STL, you can bring in the original geometry that was used. And if I turn off this bounding box, you can actually see there, I can also turn off the slice. There's the actual original geometry with the streamlines going over it. So that's some of the stuff you can do, and that's showing you how to set up ODS Studio from scratch and get to a working CFD model in just a few minutes. Alright, so I'll leave it there, and what I'll do is follow this up with more tutorials and example files that we'll put up on the website so that you can download these files and get working pretty quickly on CFD modeling and so on. Alright, thanks for listening.